All right, fun with GIS, working with broken data. I've got an empty map project, and I'm just going to add, like I said in the instructions, just the points shapefile. All right, points are added to the map, and I see a great distribution. It looks like the base map changed. So we could maybe wonder if these are a bunch of points floating in a lake or the ocean. Let's zoom out and see where they're actually located. If you have other data in your map to start with, and then you add this data, you may not see it. It may not appear in your map viewer. It may be something that you have to go search for. Or if you're zoomed out to this extent, you'll see that they just display as one point because they're stacked on top of each other at this scale. So let's inspect what might be going on here. We know this data is not supposed to appear in the ocean. We know that this is data from the contiguous United States, but we're not exactly sure what it is. So let's take a look, first of all, at the properties and the source. And this all makes sense. Let's look at the extent. It's saying here that the northern and southernmost locations for this data set, or the extent, are located at latitudes 41.76 meters north and 37.1 meters north. So it's basically telling us that there's only about 4 meters from north to south for the extent of this data. And from east to west, it looks like we're about 5 meters wide. And so that would make a lot of sense because it is a really small data set and seemed very close together. We had to zoom in or zoom out quite a bit. So if I zoom to the layer again, look at this scale. It's 1 to 31. And if I grab the measure tool and just kind of measure across it, yep, it's about 5 meters across and about 5 meters down. So that jives with what we just saw in the extent. So what's the trick here? What's broken? And what I want you to know, first and foremost, is that these coordinate values are embedded in the data. They belong to the data. They define the data. But the units of measure are not connected to the data set. These are attached when the coordinate system is defined for the data set, or if the data comes in with an undefined coordinate system, it will borrow the coordinate system from the map display, which is usually connected to the base maps, which will be a projection, and use those units of measure to define where these numbers should locate us. And so by attaching meters to these very small values, we've plotted up these points exactly where ArcGIS is telling itself to, which is within, 2 to 3 meters of the origin of whatever coordinate system we're displaying the map in, which looked like it was probably the equator. It looks like, let's back up one more step here and look at what coordinate system we're displaying in. We're displaying in the North American datum, but UTM zone 12, which makes a lot of sense when we zoom out. When we zoom out, you can see we've got this kind of funky shaped map. UTM zones, when we display UTM zone 12, it's going to show us UTM zone 12 and then I think like 6 UTM zones on either side of it, and then it just doesn't display anymore because the distortion visually gets so extreme. So that's what we're seeing here. We're seeing bands of UTM zones that should be centered around UTM zone 12, which is right in the middle here. All right, let's look and see what coordinate system the data has. Like where did those meters come from, right? So we're going to look in the spatial reference tab. And yeah, okay, this data was actually assigned the projected coordinate system, North American datum of 83, with the projection UTM zone 12. So somebody must have gotten a hold of this data and then known that it was going to display up in UTM zone 12, and so just went ahead and ran the project tool, or maybe the define projection tool actually, and defined this projected coordinate system to the points. The problem is the points are defined by this extent. The points have X, Y, or latitude and longitude coordinate values that are defined in degrees because they're angles. But whoever got a hold of this data jumped the gun and said, but I want to display it in Utah, for example, so I'm going to go ahead and project the data right away. You can't do that. First, you have to honor the intrinsic coordinate values that are assigned to the data, and they can be viewed when you look at the extent. These are very small numbers. If they were truly measured in meters away from some origin, it would be pretty weird that your study area is right next to the origin and such a small space. All right, how are we going to fix it? There are two tools that deal with coordinate systems. The first one is called project. It's confusing. It looks like the word project, which is what we work in ArcGIS Pro, but it's project, and that's the tool you use if your data is defined correctly in space, but you want to change it. For example, you download a DEM from the USGS and it comes in a geographic coordinate system. That's correct. The USGS doesn't know where the data is being downloaded to and for what purpose you're going to use it. So it's up to the user to define the projection that you're going to use. So project is what you use if you want to mathematically transform a data set from one correct coordinate system to a different coordinate system. The second tool is called define projection. Define projection wipes out any existing assignation of a spatial reference and allows you to start fresh. That's what we want to do here. So I'm going to search for define projection. And it gives you a heads up that the input data set is going to be modified. If you're concerned, you can go into your catalog and make a copy of this data first. But we know our data is already broken, so we really can't hurt anything at this point. So I'm going to choose my points. This is the coordinate system that the data set is already in, but it's incorrect. We need to remove that and try again. Because we know that those values are so small, we know that the units of measure need to be degrees, which means it needs to be assigned a geographic coordinate system. So latitude and longitude. We have a couple of options for North America. One is the North American datum of 1983, and the other one is the World Geodetic Survey of 1984. They're very, very similar in North America and shouldn't make any measurable difference. So I'm going to stick with North American datum of 1983. Run that. You can see that points just moved themselves. So ArcGIS went in to the geometry or the .shp file for these points and looked at the actual coordinate values and assigned them the unit of degree, which matches with the fact that they're angles and not meters, which means it's a Cartesian coordinate system measured on a planar surface. And you can see that they're drawing in the right place, well, at least what we think is the right place, but they're all here in Utah, which makes sense for me since I work in Utah and it's UTM Zone 12. And we're still displaying the map in UTM Zone 12. That hasn't changed. So we're still displaying these points in a projected coordinate system, even though they have been correctly assigned a geographic coordinate system. That's called projecting on the fly, and it's something that ArcGIS Pro does really well, but it can cause problems when your data isn't defined the correct spatial reference. Okay, let's say we do want to project this data, which I don't recommend doing for vector data because it kind of decreases the precision of the data every time you mathematically transform. But let's just say for some reason we absolutely have to. This time we want to use the project tool. We're going to project, we're going to input our feature class, our output data set. We're going to call it points project. I'm going to call it points UTM. Just to show myself that I've gone ahead and put these in UTM zone 12. Here we can say we want the output coordinate system. We can borrow it from the map because it's already there. And I just know that because we checked the map just now. We don't need to deal with the geographic transformation because we're going from the North American datum of 1983 to the same datum. Okay, and now if I look at the UTM points properties and we look at the extent, you'll see that those values have been recalculated. So the extent is a way to see the geometry that's defining where these features exist on a map. Now we have units of meters, which is correct for the projected coordinate system we just assigned it, but these have been recalculated to truly represent the locations in UTM zone 12 with the datum of NAT 83. So I hope that makes sense. The take home is that these values are the inherent piece that defines where the data are located. These have to be mathematically recalculated in order for them to change. But if you get a data set and see a disconnect between these two, that's where you want to start, but you need to honor the numbers, not the units. So the other thing that you'll see sometimes is great big numbers, like this is 4.6 million. Here's my decimal right here. And this will say degrees. And nothing will display on your map because that's impossible. There's no such thing as 4.6 million degrees of latitude or longitude. So it's just a geographic and a geometric impossibility. And so in that case, you'd have to figure out where does this data belong and then assign it the correct projected coordinate system, which is really tough because the projections, there's a lot more of them. And it's a lot harder thing to do. In that case, I would probably go to the source, figure out where the data came from, and search the web or some kind of website, or ask the people that collected the data. Anyway, I hope you were able to work along with that. And if you have any questions, please let me know.